Hello everyone, welcome to another episode of Reconstructing Cave Story. This episode is about creating a simple collision rectangle. Right now we have a composite collision rectangle made up of like 4 different rectangles, left, top, right, and bottom. But this time, at least for our Power Doritos, we want to have just a simple collision rectangle, which is just a single rectangle instead of 4, because 4 is way more complexity than we need for it. So our solution is just going to be to split out a composite collision rectangle, which is right now what we're calling our collision rectangle, and we'll make collision rectangle into an interface so we don't have to change any of the other code, just the internals. So composite collision rectangle will again be made up of 4 rectangles, top, left, bottom, and right. But simple collision rectangle will just be made up of 1 rectangle. So it's only going to store 1 rectangle and then calculate the left, top, bottom collisions from that. But since simple collision rectangle is made up of only one rectangle, we need to make sure that simple's bounding box is a little bit bigger than its rectangle. Otherwise, when we update X, we will still be colliding. So I created a little graphic, and it's a little bit cheesy, and it doesn't look that great, but it's better than my ASCII art, I think. So on the right here, we have our composite collision rectangle, and this is again made up of 4 rectangles. So the red delimits a collision rectangle, and then this light blue outline delimits, it refers to the bounding box. So as you can see, this is after collision, and it is still bordering with the ground, which is this black here. So you can see that this Y collision is still bordering with the ground, so it's still technically colliding. And this is what we want so that we can set on ground to be true, and on the next frame we'll know that we're still colliding. And that's exactly what we want, and which is why we split it up into multiple rectangles. But when we're doing just a simple collision, if we end our Y updates and we're still colliding with the ground, since we only have 1 collision rectangle, we'll be colliding with the X collision rectangle too. So you can see how our X collision rectangles are not colliding with the ground at all, even though our Y collision rectangle and our bounding box is colliding with it. So we need to make our bounding box a little bit bigger than our collision rectangle, and that's just hopefully this graphic helps explain it. If not, you can just get rid of the extra offset that we're adding and see how it works and play around with it yourself, but this is what needs to happen in order for it to work as a single rectangle. So without further ado, let's get started. So I'm going to start by creating a composite collision rectangle.h. And this is going to be identical, literally identical to what we have in collision rectangle right now. So let's include collision rectangle. We're going to be implementing it as an interface in a little bit. And then let's also include assert. So I'll go into collision rectangle.h and just copy everything from there. So collision rectangle.h. Copy the whole struct, paste it in. I'm just going to change collision rectangle to be composite, and then I will inherit from collision rectangle. So now let's go into collision rectangle.h. Let's get rid of our constructor first of all. We don't need that anymore. And then let's change these all to virtual pure methods. So let's try to do some magic. Virtual d modulo equals 0. I'll try that again. Oh well. Virtual I'm cutting my losses. I tried to do a macro and it didn't work. And then let's get rid of the private data and then also create a virtual destructor. So virtual collision rectangle equals 0. Implement it as inline. Now let's go to our player class where we're using this composite collision rectangle and make sure that that's working right too now. Well, it's not working right now. Let's include composite collision rectangle instead of collision rectangle.h. And then here where we're creating k collision rectangle, let's create a composite collision rectangle. And then we should be able to build and run and still see the same stuff. And I do see the same stuff, and this makes me happy. So let's do simple collision rectangle next. So simple collision rectangle is going to be a lot like our composite collision rectangle. So I'm going to copy and paste all of that, add new item. I'm going to create a .h and a .cc file. And I'll explain, I guess, when I need to. Add new item. Header guards. Actually, you know what? I'll copy and paste now. So I'll go to the top. We'll need our insert still, so let's just copy everything, including the struct. Paste it in, and instead of composite collision rectangle, we'll do simple collision rectangle. And then instead of taking 4 different rectangles, we'll just take one, and we'll call it just rectangle. And then let's go to our private data and just have one rectangle to store. So this is why it's simple and not composite. And we'll just initialize this one rectangle. So rectangle, rectangle. Our bounding box is going to be completely different, and in fact I'm going to implement this one in the CC file, and again I'll show you why in a minute. Left collision, and actually everything is almost identical except every time we see left, top, right, or bottom as the rectangles, we can just change those all to one rectangle, just the one rectangle. So I'm just going to literally find and replace every instance of left underscore with rectangle underscore. And then I'll do the same thing with right and top underscore and bottom. So as you can see, they're really similar. It's just a matter of the composite uses 4 rectangles, and this just combines all 4 rectangles into one rectangle and just pretends like it's one big rectangle. So now let's implement our bounding box. I'll go into our CC file. And the reason I'm doing a CC file, I'll tell you now, is because I want to create a single constant, and I don't want to create that constant in the header file because then it would become global, and I don't want that. So simple collision rectangle, bounding box. So let's return our rectangle. It's going to be our rectangle dot left minus some offset. So let's do k extra offset. This is so we can make, again, so we can make our box a little bit bigger than our actual rectangle. So you see this is the bounding box, this light blue, and this probably is blending in pretty well with the background, but let's see, maybe if I change the color of the background to something like green. That didn't work. Tolerance 0. There we go. So now you can probably see it better. It's this light blue background, or light blue bounding box. Anyway, back to this. So we got to create an extra offset. Let's create a namespace. No, let's not do that. We don't need one. Const units of game k extra offset. And this will just be a sub-pixel value of like 0.001 f, just some really small value. Like, because we don't want to move it a whole pixel off, but it's got to be enough so that it doesn't think it's still colliding. So I just played around. 0.001 f seems like a good number. Top. The width and height, we have to add 2 times the extra offset because now we have moved up and to the left a little bit, so 2 times k extra offset. And for height, same deal, 2 extra offset. And that should cover our simple collision rectangle. So I'll build just to make sure that this all compiles correctly, and it should. And it did. So we'll actually get around to using this in the next episode. Again, hopefully this makes sense to you. If it doesn't, after we, and by this I mean the whole extra offset stuff. If that doesn't make sense to you, then we'll be implementing our Power Doritos in the next episode, and that will use a simple collision rectangle. And you can, not use the offset, like play around with different offsets and see how it's affecting things. And yeah, just play around with it, guys. There's literally no consequences to playing around with it, especially if you're using like version control or something. Code fearlessly. So anyway, thanks for watching and happy developing.